Hello guys, this is Code and Code and this is 14th lecture of this number graph theory series part 1. And in this lecture we are going to study about this is going to be a short introductory video for topological sort. In the next lecture we will see the implementation of topological sort using Kahn's algorithm. So let's start. Instead of showing some examples, instead of showing you that where these things are used in a list, I'll be taking an example where topological sort is used. There are many places where topological sort is used, especially the one my favorite is in Gradle dependency resolution. And also if you have worked with Android Studio, you already know about the Gradle and dependencies and resolution and all. And one of the most important thing that I see is you can use topological sorting or finding you can use this topological sorting in operating system to find any deadlock. You can use Kahn's algorithm to find does there exist a valid topological sorting of or not, and if not, that means there exists a cycle. If there exists a cycle in operating system among the processes, that means there is a deadlock. Well, we'll take an example and see how topological sort is used. So suppose you have this dependency graph. That means this process or this whatever thing you have created the dependency graph. Suppose you have created for project management. So this is like I want to start a Django project, but before that Django is a Python library or Python framework, used to build a web application. So this is starting a Django project, but before that you need to have Django framework installed. Before that you must have Python libraries installed, and before that of course you must have at least a PC or laptop on which you are working. So this is a dependency graph of things, and the arrow indicates that this process or this thing depends upon this process. So you cannot start say a Django project and say, okay, let me finish the Django project first and then later I'll be installing Django libraries or Django framework. That is not how things work. You have to have this thing before you start this thing. So this tells you the dependencies which you need to follow, and topological sort gives you a valid series or sequences of processes that needs to be done before the other. So this is what topological sorting gives you. So suppose you wanted to finish this process. So before doing that, this process depends upon 5 and 6. So 5 and 6 must be done before starting process 7. Now 5 itself have dependencies, and 5 depends upon 2 and 4. So before starting 5 you must finish 2 and 4. Again, process 2 depends upon process 1 and 4 depends on 3. So before starting process 2, 1 must be completed or 1 must be done before. Similarly for 4, 3 must be done before. So just to complete this, there are these many dependencies, and topological sort give a valid ordering of processes to be completed for for completing certain project. So topological sort gives you a valid ordering, and a valid ordering means none of the for each process all of its dependencies must appear before it. So for 7, all of its dependencies, which are 1 3 2 4 and 5 6, must appear before 7 in the topological ordering. Similarly for 5, all of its dependencies, which are 2 and 4, should appear before 5, and for 2 its dependency is 1, so 1 should appear before 2. One of the valid for the same graph, one of the valid topological sorting or topological ordering can be this. First you complete 1 and then 2 and then 6 3 4 8 5 7 and 9. So if you see, for each process, all of its dependencies are appearing before it, which means we have to complete it's them first before starting this. For example, for 5 for 5 dependencies are 2 and 4. So you see, for before 5 we are having 2 and 4. Again, for 2 dependency is 1, so before 2 we are having 1. Similarly, for 8 dependency is 1, so before 8 we must have 1. So this is a valid topological sorting. Now, one important thing about topological sorting is that if you list down all of the nodes in their topological ordering, and then uh, you show or you draw all of the edges now in the this way, that means you put down all of the nodes in this order, in the order of their topological order sorting, and then if you draw all of the edges again, then you will find that all of the edges move from left to right, which means that this node is dependency of this and this. And this is also a valid way to check the validity of the topological sorting. If the topological sorting is valid, then all of the edges will appear from left to right. If an edge appears from right to left, what it means is that, okay, suppose there was an edge from 8 to 3, from 8 to 3, which means 8 is dependency of 3. In that case, that would be an invalid topological sorting, because the dependency is appearing after the node itself, so that would be invalid sorting. And since it's a valid sorting, we can confirm it by this graph. Simply list all of the nodes in the order of their appearance in the topological sort, and then draw the graph again. I mean, draw all of the edges again. You will see if all of the edges are from left towards right, then this is a valid topological sorting. Otherwise, if you find any edge which is from right to left, that means this is an invalid topological sorting. Well, this was all for this lecture. This was only a simple topological sorting introductory video. After this lecture, in the next lecture we'll study Kahn's algorithm. Okay, in the next lecture we'll study Kahn's algorithm and see the implementation of topological sorting. Kahn's algorithm implements topological sorting algorithm in v plus e time. So we'll see the implementation that is really easy. So in the next lecture we'll see the implementation, and after that lecture we'll sort some of the problems related to topological sorting. So this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.